Hello, this is Sarah Hardy at the University of Maine at Farmington, and this is a video tutorial in how to use R and R Commander to do logistic regression. So for purposes of this video, I've already selected this data set called coronary. So let's take a look at that. In this data set, there's a couple variables. Besides ID, there's age, which is the age of the subject, and CHD, which stands for coronary heart disease, and that is coded as either a 0, meaning no coronary heart disease, or a 1, indicating that there is. And this is a pretty common way of coding these yes/no kinds of variables. So the first thing I want to do is plot my data, and what I'd like to do in this case is actually make a box plot of age by group, where the group is coronary heart disease. To do that, I'm going to have to make coronary heart disease a categorical variable, and we've done this once before, so I'm going to go to Data, Manage Variables in the Active Data Set, Convert numeric variables to factors, and I'm going to convert CHD, and I'm going to give it a new name this time. Let's call it CHD underscore YN for yes, no, and I'm going to hit OK. 0 is no, and 1 is yes. OK. And I'm now going to go to graphs, box plot, plot age by group, and we only have one grouping variable, so it's automatically picking it, and hit OK. OK, and we will get a box plot. So notice this is the same thing we did for two sample t-test. The difference being is that now age is our explanatory variable, and the categorical variable with two categories is our response variable. If you would like to be consistent with the way we've done things in the past, and you want to put your explanatory variable on the x-axis and the response on the y, you can go up to your box plot statement, and you can add an argument of horizontal equals true, and submit that again. It's going to make the same box plot, but with the boxes horizontal instead of vertical. But I'm noticing that it leaves the labels the same. So we'll need to fix that. So I'm going to fix that in a second. Okay, so now I've changed this so that the Y label is now coronary heart disease, X label is age, and I'm going to run it again. And notice now it fixes my axes labels. One other thing you can do that you might want to do for your PowerPoint presentations, if you want to make these look prettier, you can make them different colors. So for example, I can say COL equals red, and submit it again. And so doing that fills in the boxes as red, and remember there's 600 different colors you can choose from. And this can be done for any box plots, not just for logistic regression. Okay, so next we will actually do our logistic model. And to do that, I'm going to go to Statistics, Fit Models, Generalized Linear Model, and my response variable is coronary heart disease. And I'm going to choose the one that's a factor. However, I believe that you can actually choose either one of these. We had to change this to a factor primarily to make the box plot. And so my explanatory variable is age. Okay. In this lower section, we want the family to be binomial and the link function to be logit. Those happen to be the defaults, so we won't have to change that. Then I'm going to hit OK. And my output will come up down in the output window. And we can look at this now. We can see that age is very significant predictor of probability of heart disease. Next, I would like to plot this function, and there is no quick way of doing it with the menus, so we're going to have to do it similar to the way we did some of our prediction and confidence intervals for regular regression. So what I want to do is create a sequence that spans my age variable. So the command I'm using to create that sequence is, first of all, I'm calling the sequence ageseq equals, I want to put this in a data frame, data.frame, in parentheses, age equals a sequence that starts at 16, ends at 90 by 2s. Notice that's a little bit smaller than our actual data and a little bit larger. Also notice that right here, age, this has to be exactly the same as whatever the variable is called in the data set. So since it was all caps in the data set, for example, I have to use all. The next step after creating this age sequence is to find predicted values or predicted probabilities of heart disease for those ages. So I'm going to call this variable pred chd equals predict the name of my model, which for me was glm.8 coming from here, but if this was the first one you did in this session, it would be .1. And then what I want to predict for is this age sequence with this variable. So this is important for me, and this needs to say ageseq $age. And then also type equals response. And you need to be real careful with this. If you leave any of these parts out, it won't work. Okay, so after I have my predicted value, I'm going to, what I want to plot is the age sequence. So ageseq $age and this predicted value. So I'm going to select all three of these lines and hit submit. And over here I get my plot that shows how the probability of coronary heart disease increases with age. And this is a good time to remind people that when doing plots for a presentation or a report, you need to have nice labels on your axes. So I'm going to clean these labels up a little bit. So now I've added some labels. I'm going to label my x-axis age, y-axis predicted probability of coronary heart disease, and I'm going to put a main title on it too of age and heart disease. So I will submit this and submit, and now you see the same plot but with the fixed up labels. I can also draw a line through this. I could do that by adding the argument type equals O, and if I want to get fancy, I could make this a different color too. So I'm going to say blue this time. Now I'm going to select that whole line and run it again, hit submit, and now you see I have a line through here and it's blue. For our next example, we'll do a logistic regression that has more than one explanatory variable. And for this example, I've selected the dataset Survey Fall 10, and this is actually a dataset we started the semester with that has the responses from the survey of UMF students. So in this case, what I want to predict for is the probability that a student voted based on a couple other variables. So I'm going to fit my model, generalized linear model, and my response is going to be vote in 2010, and for my okay, so I paused there a second while I was choosing my explanatory variables. And so the ones I chose to try are exercise, how many states they've been to, how many hours a week they study, how many hours a week they work, how much they spent on textbooks, and how many times a week they call their parents or another caregiver. And our defaults of binomial and logit are what we want, so I'm going to hit OK. And now our output comes up down here, and we see that the ones that are coming up significant are states, how much they work, and interestingly, how much they spend on textbooks. So with all these variables, what I'm going to try is a forward stepwise selection. I haven't had any luck using the stepwise model selection that's built into R Commander, so I'm just going to do this step by step. And what I'm going to do is I'm going to look at these variables that we had in our original model, and I'm going to kind of order them here based on these p-values. So I'm going to start with textbooks, then add states, then work, then exercise, and maybe study. So I'm going to go back up here to fit models, generalized linear model, and conveniently it's pulling these up. So let's start with textbooks, hit OK, and our AIC is 252. Next I'm going to add states. Okay, and now our AIC is 247. So that's a decrease, and so let's keep that one. Next one, I'm going to try adding work. Okay, so I've added work. I'm going to hit OK. Now my AIC is 239, so it went down again. So we'll keep that one, and next we will try exercise. Okay, so I added exercise. I'm going to hit OK. Now our AIC is 238. So it went down again, but just a little bit this time. Next I'm going to try to add study. Okay. Now our AIC is 236, so even though these variables are not coming up with a significant p-value, they are still helping our prediction enough to decrease our AIC. So next I'll try calling or adding call parents. Okay. And our AIC still decreased, so maybe I'll try adding another variable. And the variable I'm going to try adding this time is commuting distance. Okay. And our AIC is still going down now to 104, so I will try adding another variable. So I've added the number of outgoing calls. I'm kind of running low here on numerical variables to add. So I'm going to hit OK. And now the AIC is 106, so it did go up. So meaning that we should not add this last variable. I can also add variables that are categorical. So I'm going to try adding parents grad and see what happens here. So my AIC actually went down again. Now it's down to 101. And notice here in parentheses it's saying T dot equals yes. That means it's coding the ones that are yes as 1. So now I'm going to see if there's another categorical variable I could add. And I'm going to try adding gender. Okay. So adding gender improved it just slightly. It went from 101.53 to 101.35. So it looks like we should keep gender, and in this case it's coding male as true, or with a 1. Okay, so this time I'm going to try adding whether or not people are in a serious relationship. Okay, so it looks like this time our AIC actually went up to 103, so it looks like we should stop here and not include serious in our model. One small note, I do want to point out that you actually can include categorical variables that have more than 2 categories, but the interpretation gets to be more difficult, and so for purposes of this class, if we're going to put categorical variables in a logistic model, we'll stick to the ones that have only 2 categories. So I think that is about it for logistic regression, and so thank you for watching, and goodbye.